I've got this box. I have no idea what it is. I've had it for maybe 25 years. It has my name on it, so I think I bought it at an auction. It's 9, has a heat sink on the back, which puts it at 12 inches. And it's about 10.5 inches deep. Now there's some clues. There's a little removable hole here, plastic cover. It's heavy. Both sides are identical, they're perforated. Oh my God. The bottom contains some rubber feet, and I never noticed this before, but there's a BNC connector there. And what appears to be two, like, inductor or capacitor adjusters. On the back, we have a heat sink, some sort of a 3-conductor outlet, a switch that says continuous or external modulation, and an IEC connector. And it has a Perkin-Elmer serial number and manufacturer. Oh, and here it says Perkin-Elmer Corporation model. I'm reading it upside down, 05700761. It has an FCC approval number. And it draws 3 amps. On the front, we have a meter 0 to 20 watts, a broken off toggle switch. This probably was filled in with a metal bezel or a filler. It's a switched potentiometer. I assume it's a potentiometer. It appears that this would track the meter. In other words, as I turn it up, the meter would go up to 20. And it says, let me move it again, Perkin-Elmer EDL power supply. I'm not sure what an EDL system is. I know that this probably came from someplace that employed a lot of laboratory equipment, both medical and all kinds of other research. So I've kicked this around, I've stumbled over it. I'm going to find out what it is and either do something with it or scrap it. So on this side, this being the front over here, there's 4 screws. There are machine screws, that's of some value. Means it's either old or well built. Heat sink on the back would tend to imply it's solid state. Alright, I've got a rusty transformer, an electrolytic that's just out of sight here. Don't have that in camera, let me move a little bit. Electrolytic's that big, how high is that? It's probably 6 inches overall and an inch and a half in diameter. And it's rated 13,000 microfarad at 40 volts DC. I don't see a date code. So this is all aluminum. Well, it looks like there's a lot of stuff going on down below here. There's one transistor on this heatsink, internally fused. Alright, so here's two coaxial cables, two funky looking plugs. This must be some sort of a detector. Now it's powered from here. It's got a capacitor on it, some inductors, and a TL442. I'm not familiar with that. This must be some sort of a power detector. We'll turn it over and take the bottom off. That doesn't look too easy. These screws have lock washers on them. Okay, I unplugged the power connector. I'm going to have to unplug the coax. There they come. Turn this around so we can get it in the camera. So the light is obscuring this. There's a label right here that says an RF lamp driver. And we have a crystal. Appears to be a 12 megahertz crystal. I'll hazard a guess and say this is some sort of an oscillator. Amplifier output. The screws on the bottom that I thought could be adjustments are actually just threaded stems on these amplifier transistors. 8129. $81.28. By the way, this is a 4627. A 12 megahertz 20 watt RF source, perhaps. Try to put it back together. And we'll see if it works. One thing I noticed when I was powering, well, I haven't powered it up yet. There is a switch here called off and power. Well, the label says off. I assume it's power. There's also a toggle switch here, off and on, which is broken off. The toggle switch appears to switch the AC inlet voltage, where this potentiometer and switch connections go down into the board underneath. So I've got the power switch on and this rotary switch off. I've got a cable hooked to the BNC connector. It goes through a series of attenuators to both my spectrum analyzer and my oscilloscope. And I'm going to power it up with a Variac, probably about half voltage. which I've done there. So I'm assuming now that this power supply is powered on. I did see a little inrush current on the ammeter, and nothing happened on the oscilloscope, that is. I'll increase the voltage to about 120 volts, and still nothing. Maybe this was thrown away. Now I'll have to do some troubleshooting. Although I did see some inrush current when I turned the variac on. I'll try again once. Alright, I saw inrush current, which would tell me the power supply is on. No indication on the wattmeter that anything is happening. So there I have 27 volts DC. I wonder what the switch switches. Okay, the switch turns on the DC voltage to the stuff down below. And there it is. So we're turning on and off the supply voltage to this RF board down below. Well, as often happens when working with this old equipment, I took it apart. I got the coaxial cables out of the case and back into their appropriate holes. I plug this in. It's really tight. I'm really stretching the wires. I'll turn the RF on. You see in the oscilloscope, 27 megahertz. RMS voltage of 8. Now I'm going to exceed the capacity of my oscilloscope here. I've got an RMS voltage of 23 volts. That equates to at least 10 watts. However, I've got no indication on the front panel meter. So the power indication circuit is bad. I am drawing a little more than an amp of AC power, and touching the dummy load, it's getting hot. I mean, I can lay my hand on it, but it's pretty hot. So I'm not sure why it started working. I'm not sure why it's at 27 megahertz. I'm pretty sure the crystal said 12. They could be doing some doubling, but the frequency is 27.12 megahertz. When I turn it down, it goes to 8 volts RMS, 9 volts RMS, which is about 2 watts. So 2 watts to about 10 watts. Looking at the two voltage regulators, this first regulator receives 24 volts and outputs 12 volts. This regulator receives 12 volts and outputs about 6 volts. This entire portion of the circuit board is at 21 volts. I believe this to be the output of this first that little device. That reached 21 volts. This is the next device. And my meter doesn't like that. It locks the meter up. This one, 21 volts. So we have unregulated voltage going to these two devices. This reads 6 volts, so that's apparently the voltage to this oscillator stage. Then these next two stages are powered at 27 volts. Well, it's 24 volts there. 21 volts there. 21. 12. 24. 21. So there's a diode in here somewhere providing a little bit of drop. There's a jumper here. I don't know what it does. So I'd say this thing's working about the way it should. I just burned myself on the dummy load. I don't know what impedance it was designed to operate at. I'm operating at 50 ohms. This coaxial cable gives me no indication of actual impedance. It would make a good citizens band amplifier, perhaps. Or jammer. So that's a look at a piece of 1990s technology. It has a lot of air in it. Case could be a lot more compact. Probably extremely conservatively designed. This metal plate is probably 3/16 of an inch thick. It's hot. Serves as a heat sink for this. And behind it you see the heat sink, you saw at least. The heat sink for the voltage regulator.